Good morning, everyone. Our first keynote speaker for the day is Dr. Stephen P. Mulva, Director, Construction Industry Institute, more commonly known as CII, a not-for-profit research center at the University of Texas, Austin. In addition to his responsibilities at CII, Stephen also teaches graduate courses in construction engineering and project management at the University of Texas. Dr. Stephen P. Mulva holds a PhD in civil engineering from Georgia Tech and 2 engineering degrees from the University of Texas at Austin. Before coming to CII in 2007, Stephen was a professor at Texas State University. He has also held various positions in many reputed companies such as Fluor, Bechtel, Phillips Petroleum, besides serving as a project management consultant for EPM. His current research projects are focused on improving the business outcomes of capital projects in most sectors of the modern economy. And despite the time zone difference of more than 10 hours between Austin and India, it's close to midnight now there, Dr. Stephen P. Mulva very graciously accepted our invite to be a keynote speaker for this seminar today. We look forward to hear from you. Over to Dr. Stephen P. Mulva now.
Thank you, Ganesh, and good morning to everybody. I'm really delighted to be with you. It's just after midnight here in Texas, and but I'm excited to share with you some really exciting news and research that we've been doing at CII. Really also pleased to be on the schedule with Ben Breen. Haven't known Ben for very long, but we've been collaborating closely with PMI on helping to build a construction management education and certification program, and so that's been really exciting for me as well. I'm going to share my screen here, and hopefully you will see it. Okay.
Yeah, we can see that now.
Great, thank you. So. Yes, I'm going to talk about some breakthrough opportunities that we see in infrastructure project management. In particular, I think that there's a real potential for us to be able to build projects in half the time at half the cost in very short time frame, maybe 3 to 5 to 8 years from now. And I'm going to explain why I'm so optimistic about that. I like the intro. That talked about our huge infrastructure spending in the United States, over $2 trillion proposed by our president recently. Our infrastructure in many cases is crumbling, and it's going to take all of us in project management and the engineering and construction industry to fix it. I just wish we'd get even more infrastructure for the money, and so I'm going to talk about some strategies. Before I start, let me just say real quickly, I think what we do in this industry, and it's probably one of the biggest industries in the world. Most people say it's about 13% of gross domestic product in any country. It's a little less than 10% in the US. But I think it's the most noble industry that there is, because you can't have transportation, energy, food, healthcare, education. You can't have any of these things unless we first have a project. So we're kind of the center of the built environment and the center of civilization. But we have to improve. We have to be better. And improvement generally takes several different forms. Most people like to talk about improvement in people, education, things like PMI and that CII provide, if we can educate people. Process, improve your work process. Technology, increasingly leveraging new modern technology to be more efficient. But I'll say there's a fourth one, and I'll get to this too. It's business model. I think we have to redefine our business model in engineering and construction, and I'll talk about an effort called OS2 real briefly that we're taking on at CII. 2 other concepts before I get started: predictability and capital efficiency. So most of the improvement efforts that we've made in our industry is on being more predictable. So we have this strong focus, hey, be predictable on cost, on schedule, have good safety, have good quality. The problem is that we can be predictable with a fat estimate. So we can just add a bunch of buffers and contingencies, and we can come underneath cost. But that's the opposite of capital efficiency, where we're trying to get the most value for the money. How can we stretch every single dollar, every single, all the money that we have, how can we get the most value out of it? And increasingly, I think that's where the world is moving. The owner-operator firms that we have as members of CII certainly are talking to us all the time about capital efficiency and doing more for the money that they're investing. So real quickly about CII, we're almost 40 years old. We're a not-for-profit part of the University of Texas. We have about 130 companies, typically about a $7 to $10 million annual budget. We're just about the only industry-funded research center for engineering and construction in the world. And we're best known for our best practices. So the term zero as related to construction safety, that came from CII. So a lot of the innovations that we have were either invented or formalized through some CII research, things like constructability. I'm going to talk about PDRI. Advanced work packaging is the newest, latest, greatest thing that's out there. All of these things are searchable on our website for free. You can go on our knowledge base and you can read about the 250 different research projects that we've done. And I'm going to talk about a couple of them here. Real quickly, half our members are owner-operator companies. They're in all kinds of different industries, but certainly a lot of infrastructure projects. The other half of our members are engineering, procurement, and construction companies. Many of them have operations in India, and so we're quite active there, and that's one of the reasons why I'm excited to talk with you all today. We have a pipeline of research that's ongoing. We have an annual conference every summer. There's eight different research topics that we're launching this summer. We're doing a lot of work in workforce capacity. There is a tidal wave of work coming towards us, and we have to make sure that our both at an engineering level, project management level, and a craft professional level, that we have enough people and with the capability to do the work. We're increasingly looking at integrated project delivery, safety, circular economy, a number of things that are going to really impact our business as we move forward. And typically we produce this academic research using the best faculty and students from around the world, and show this to our companies and the wider industry, as I said, every summer. There are four main things that we're working at right now. The first you see, and read the rows here in yellow, capital efficiency. That is, how can we get more for the money? Part of that is measurement. Part of that is also integration with the business side of capital projects. So really even looking at things like tax law. Advanced work packaging continues to move ahead. If you're not familiar with advanced work packaging, imagine if you took a construction project and you broke it up into discrete work chunks, almost like you were building a piece of furniture from IKEA or a Lego set. You would have work instructions, and it would be discrete pieces of work in construction work packages and engineering work packages. This is a game changer. It's really saving a lot of money and a lot of time, and I'll talk about it a little more. The others, toward the bottom, tool concierge. We have over 100 tools, and I'm going to talk about PDRI today, but we have to integrate these a little better. We have to make them into a digital workflow. A lot of the companies are integrating digital workflows in their work. And then lastly, environmental social governance. There really hasn't been a lot of work done in this area, especially on the social justice part for capital projects, but increasingly we've got to do a better job of sustainability and environmental issues related to capital projects. So in infrastructure in particular, let me talk first about achieving predictability. And the best way that we've found to do this is through scope definition. So we created a number of years ago, starting in the 1990s, something called PDRI, Project Definition Rating Index. So this is a way that you can gauge the level of scope definition that you have early on in a project. And it started in industrial projects and moved to buildings. But in 2010, we launched something in infrastructure projects, and that's called IR 268-2, or you can just refer to it as the infrastructure PDRI. Now, the way that CII defines an infrastructure project is it's anything that connects A and B. So it could be a rail line, it could be a highway, it could be a power transmission line, it could be a pipeline, it could be a number of different things. But a lot of times the infrastructure projects that we find is you may need multiple of these PDRI assessments. An airport, for example, would have a land side consisting of the runway and the land infrastructure, and an air side, the terminal. And so the terminal might use a building PDRI, the rest of the airfield would use the infrastructure PDRI. But this really, the PDRI really achieves predictability, and it does it in three basic areas. The first is we have to make a good project decision, and there's 1,000 points. And a really bad project that has horrible definition would have 1,000 points. So you want to have a lower score. A lower score here is better. For infrastructure, there's 68 different elements that a project team has to analyze. And the most points are actually in making a good decision about the right project. That's 500 of the points. The basis of the design is about 350 points. You want to make sure you have the right product, the right design. And then the execution is the last 150 points. Do you have a good project execution plan and strategy? And the way that it looks is something like this. You would facilitate a session with the project team. You would have a score sheet, and you can see this one of these top rows. A poor definition would be a level 5. It would A1 on need and purpose documentation. You know, if you had very incomplete definition, you'd score a 44 on that element, and you would proceed through all these other elements. The goal here is to actually have a score below 200. So it's like golf, you want a lower score. Each of these elements has its own definition. So there's a description. This one I'm showing right now is a description about looking at the right-of-way for an infrastructure project and creating cost estimates for that right-of-way. So acquiring the land, I'll say for a highway or a high voltage transmission line. We really have a lot of checklists. This is a way that you make sure that you have fully considered everything, and essentially everything at CII is that way. There's lots of tools, lots of checklists, because you want to make sure that you fully thought through everything in the project. So a project team would look through this and they would say, okay, we did a good job, we have very complete definition, or we didn't do a good job, we don't have very good definition here, we need to do some more work. And you want to get to a good score before making a final investment decision. So the research that we've done shows that if you have a score of less than 200, you have a much better project outcome. If it's over 200, 25% cost growth, 30% schedule growth. So the score under 200, having good scope definition, makes almost a 20% difference on cost and a 15% difference on schedule. Now somebody would say, well, yeah, but look, I used your tool, I got a score under 200, I still have a 6% cost growth, 15% schedule growth. That's still not all that good. Well, it's better than the alternative, but what's the problem there? And we did do some research. We looked into that. And what we concluded was that this additional cost and schedule growth was due to the changing and impact from regulations. Government regulations, other policies and procedures that surround infrastructure projects throughout its entire life cycle. That this was a huge problem. And so a couple years ago, we created a tool that we could look at how do you identify and evaluate the impact of changing regulations while you're doing an infrastructure project. Infrastructure projects, if they're really large, could take 3, 5, 7 years to do. And during that time, the government can change their regulations substantially. The question is, how is the project team going to respond to that? Would they change the design? Would they make big change orders during construction in the field? And those are things that give rise to those cost overruns, those schedule overruns. So if you pair the infrastructure PDRI with this new look at how to evaluate the impact of changing regulations, we can be very predictable on our cost and schedule and actually have much better safety results. But if you think back to when I started, I said, okay, we have to have predictability. That's good. We also have to have capital efficiency. So now I'm going to tell you how we are going to be, and this is the breakthrough part of infrastructure projects. How are we going to be incredibly more capital efficient going forward? The first one I'll tell you is advanced work packaging. This started probably close to 10 years ago. It's in widespread use in the heavy industrial sector. So people who do petroleum refining, make chemicals and plastics, power plants, and it's growing quickly. The next big area that it's going to get into is infrastructure. And there are some firms, Bentley Systems does design software specifically for infrastructure projects. They are all in when it comes to advanced work packaging. It originally started because we were looking for a productivity gain. We wanted to make sure that the workers in the field had the materials, the design information, the equipment, the labor, everything was ready to go to be productive. What we discovered was that there was a big cost and a safety benefit to this. If you were well organized and you were productive, your cost structure came down, you met your timelines, and above all, you were much safer. We think we can improve upon this because this is still a bit of a manual process. We're going to apply artificial intelligence and machine learning to advanced work packaging. This is one of the research projects we're starting right now. We think we can use the computer to continuously resequence the work packages based on, I'll say, material deliveries, or if designs are still being worked on. Every night, the computer can recalculate and resequence these work packages. And we think we can get in the range of 15% cost savings pretty easily in the next couple of years. And that's total installed costs. So reducing the cost of a project down by 15% is quite large. The next one is, I'll say, going all in on PPMOF. And if you haven't ever heard of PPMOF, it's a acronym that we created a number of years ago because we're engineers, we love acronyms. It stands for pre-assembly, prefabrication, modularization, and off-site fabrication. So it's a collection of constructability and modularization techniques that put together can really yield some big savings. So we started applying this, and these are results that we've been studying for the last 3 years. It's applied to chemicals. But one of the things I want you to think about is you may have seen these videos out of China where they created a high-rise hotel or apartment building, could be 40 stories tall, and they built it in 30 days, right? And these videos have been around for some time. Well, how did they get there? It was all in on a pre-assembled, prefabricated strategy. So we started applying this to more of an infrastructure project, a large chemicals project. And what we determined was that we're building too big. So instead of building one very large plant, you should actually build 10 small plants. Each of them are completely self-contained. What we found was absolutely remarkable, and it applies to infrastructure projects as well as heavy industrial. The cost was 87% less for the same capacity. The footprint was 50% less. It took 70% less time to build. And people said, well, now if you have 10 little plants instead of one big one, it's going to cost a lot more to maintain. But you can see here, 14% less operating expense. It was actually cheaper to operate. So between the reduction in the capital expense and the reduction in the operating expense, much more net present value, almost double the net present value was being generated as an investment. So this is huge, and maybe it's harder to apply like in a road, but certainly in a bridge, we can, and certainly in a lot of other infrastructure projects, we can do a lot of pre-assembly, prefabrication, modularization, or offsite fabrication. So the last thing that I'll talk about where I think there's really big potential for savings is in this area called Operating System 2.0. And really, people haven't investigated this at all. This is just the business side of doing engineering and construction. We looked at it and said, actually, 41% of the cost of a large capital project, large infrastructure project, is transactional waste. This is money that does not go into the engineering, the project management, the labor, the materials, the equipment. It goes into things like finance charges, excess fees, duplicate insurance, cost of claims, wasted logistics, et cetera, et cetera. So there's a couple big categories on here. The orange part where it says non-value added field operations, that's the cost of poor productivity. That's people waiting on materials, waiting on information. And we're tackling that largely through advanced work packaging. This one at the top in pink where it says trade credit. One of the issues in our business ecosystem is we have multiple layers. In fact, on a very large billion-dollar type infrastructure project, there's typically 10 to 12 layers of contracts. So you think about banks, owners, EPCs or large contractors, subcontractors, distributors, reps, suppliers, raw material suppliers. It's a cascade of contracts, and they're all getting paid late. If you put some work in place this month, on average in our industry, it takes 74 days before you receive payment. That means that you have to essentially float a loan to the people that owe you money. And that costs a lot of money. In fact, it costs upwards of 15, even 17%. People add an additional 6 to 7% just to their bids because they know they're going to be paid late. So we said, this is crazy. We should be able to tackle this. And one of the modern technologies we're applying here is blockchain. So with smart contracts and blockchain, we can be paid instantaneously. We can cut the 74-day payment terms down to 1 day. And we started to do that. And then we also were looking at risk. People have a lot of contingency and management reserve they're adding to their bids unnecessarily. We actually this week just completed about an 18-month study on risk, and we concluded that we can cut the total installed cost of a project down by 17% purely by having a blockchain approach to pooling and mitigating risk. It's absolutely breakthrough. Just really nobody has tackled this before. And so, blockchain is a key technology in this. I think, having a better, smarter contracting approach is key to this as well. But if you take these things together, advanced work, have better predictability through things like PDRI, but then really focus on capital efficiency, advanced work packaging, OS2, all in on pre-assembly, prefabrication, modularization, to the extent that you can do it. All of these things are going to make absolutely breakthrough results, way better results than we've ever had in infrastructure projects before. So my last slide here is I bring this all together, and I call it the big picture. There's a little bit of math involved here, but conservatively speaking, I feel very confident within the next 5 years, we're going to see infrastructure projects that have a different approach to business. And I think the type of savings you're going to look at there is on the order of 30 to 33% of total installed cost. All in on pre-assembly, prefabrication, modularization, and offsite, you're going to get upwards of 30%. On average, I think about 37% savings of total installed cost. And then advanced work packaging is another 14%. Now you can't add these all up, and if you did, you'd say, well, that's 71% cost savings. It doesn't work like that because some of them are the same cost savings. They kind of work together in an integrated fashion. So the way we calculate that is this formula. If you want to look at the combined savings from 3 different things, it's the square root of the sum of the squares. So it's 33% squared plus 37% squared, and the answer is 51%. So at the start of my session, when I said, I think we're going to do projects in the future in half the time and half the cost, this is how I think we're going to get there. All in on AWP, pre-assembly, prefabrication, modularization, and a different approach to the business model. What does this mean, though, for I'll say, people who are in the engineering and construction business? I think it's a radically different type of business we're going to get in. I think the revenues are going to be quite a bit lower, but I think the profitability is going to be substantially better. The revenues, I think, will be cut in half. And you see this because if the cost of the project is half, the revenues would also be cut in half. That's logical. But we need to have about 300% better profitability for the engineering, procurement, and construction companies. In the US, the publicly traded EPC firms last year performed at -0.5% profit margin. So they lost 0.5%. That's not going to work. With that kind of result, they can't invest in training their people. They can't invest in technology. Normally, they're making about 2%, and we think we can bring that up to about 6%. And at 6%, we can pay people better. We can train them better. We can hire more people. We can invest in technology. We can do all those things that will have a healthy industry, and that will sustain this type of innovation going forward. So this is my story. I'm sticking to it. I'm incredibly optimistic about what the future holds for infrastructure projects, big projects in general. And I appreciate your time today listening to me. I don't know if we have any time for questions, but if not, please jot down my email address there, and I would love for you to send me an email, and I'm happy to respond to you about anything that I talked about today. Otherwise, I think I'll turn it back over to Ganesh or Tony and see what's next.
Thanks, Stephen, for delivering an excellent presentation. We do have a couple of questions actually, which we'll take on. The first is, how is the adoption of agile project management happening in ENC projects? Is it welcome, or waterfall still the preferred method of project management?
Yeah, I think we have to really look for opportunities to bring more agile project management in. And I think that's also one of the things that we're looking at. When I talked about having the computer resequence the work packages, that's really an agile approach. We can leverage the computing power and human intuition, but even how we set up the projects are still a little too sequential. I'm quite concerned with the stage gate model. They do that to ration capital. Big owners do that, but it tends to be pretty slow and bureaucratic. So I think even changing that up is going to be important. And one of the ways we see that is digitalization. So as we have digital workflows, we can be more agile, we can be quicker, we can do things in parallel. The processes right now are very serial, they're very sequential. Yeah, that's a big thing. The problem we have with it though is that what we do is a very physical reality. So agile project management, you can do it in software because there's not really a physical reality to what you're creating. You're creating software. For us, we're creating roads and bridges and all of these kinds of things.
Yeah. Then the second question that has come in is, can you elaborate on lean and smart contracts? What is it and how is it implemented? Can you just a little bit elaborate on that, Stephen?
Sure. So, I mean, lean at its core is just you're trying to get rid of waste. And I think that's one of the reasons why I was talking about, OS2, that we have all these transactional wastes in our business model. So we can get rid of waste. I think there are project controls procedures like last planner methodology, and I think those things are excellent, and we need to be incorporating those. But in getting rid of waste, we can use smart contracts. And the smart contract, all it does is it's basically like a normal contract. It's just that you've now embedded it in the computer. And so when something happens where you can get paid, and you can recognize that event, the transaction can happen much faster. So there's a lot of paperwork in our industry right now. We have to verify that somebody installed that. We have to write written reports. We have to file quantities. You know, it's a very labor-intensive process, and so we can get rid of a lot of that transactional waste even through the smart contract. And you know, what we want to get paid for is the excellent planning, project management, engineering, construction, you know, equipment, materials. That's what you do want to pay for. All this other stuff that's sort of secondary to the process. And by the way, there's a lot of people making a lot of money off that. I mean, the law profession, you know, every time we mess up and something goes wrong, they make money. So the less that we can mess up, the less money the lawyers will make, and the less the projects will cost. So, you know, sorry if I'm offending any attorneys out there, but it's, you know, this is one of the better we can do our jobs, we can get rid of a lot of that waste.
Yeah, agreed, Stephen. And just, I think you have already elaborated, because the next question was on the lean practices adopted in OS 2.0. I think you have touched upon that in your reply.
Right.
And
yeah,
then,
we're looking at that too. Yeah.
Okay. And the last question before we move on to the next speaker is, can you please elaborate on the blockchain usage for this, and how do you, I mean, if you have any specific example, just a quick one before we move on, Stephen.
Sure. We actually have 2 pilot blockchains right now. One is on this issue of payment terms, and trying to speed up the receipt of cash for putting work in place. So, and there are people who've done this in other industries, but it's really in its infancy in ours. So we're looking at that one sample blockchain to see how with smart contracts to get people paid faster. Somebody installs structural steel, you know, hey, look, we just installed 10 tons of structural steel. We want to get paid now, not 75 days from now. And so we're studying that. The other blockchain is being built on Hyperledger Fabric, and it's really risk. And what we're doing is, let's just say you had 20 companies and they all perceive different risks, but they're unwilling to share with each other exactly what those risks are. So they can put them on the blockchain, and that can be secured, and they can see all now everybody can see all the risks, but nobody knows whose risks they are. And it's really the bridge that we needed to have a different discussion about risk. And that's where I was saying the latest results really just this week were showing that 17% total installed cost reduction by using this blockchain and risk is totally achievable. So that's just a huge, really promising result. We used to always be happy when we get like a 1% finding or something. I mean, we're finding it in big chunks. So 15% in AWP, 17% in blockchains with risk. I mean, they're big chunks of savings.
Okay. Thanks, Stephen, for delivering an excellent presentation. And just as a small token of appreciation, we just want to give you this certificate of appreciation, which we'll be emailing to you later for giving this presentation. So thanks once again, Stephen.
Absolutely.
Thank you. Thanks.